In this lesson, I'm going to be showing you some of the new numeric filters in snowFlaKe version 3. Uh, really powerful filters for terrain, procedural terrains, and also controlling materials. I'm going to go ahead and add in a procedural terrain. And if you hit Control E on the keyboard, you can edit the object and open the terrain editor, or you can right-click, edit object. There's a couple of different buttons in the interface for this as well. Up at the top, it looks like there's a gear next to a box. That's the edit object. So in case you're working in the Extreme Integrated version, and you're using the icons, you'll find them in a couple of different places. The object properties is going to be the aspect tab, where you can edit the object from there if needed. Now, the first filter we're going to take a look at is the advanced zero edges. Within the terrain editor, what we can see is that we have the edge removal of our terrain, which is a very constant amount. That's something you really can't modify. It is a multiplying, basically kind of a Gaussian, the tooth Gaussian noise node, it looks like, which is what the original zero edge function filter performed, and did the same operation within the function. That was something I designed as an earlier version of this. Once Vue 9 came out, there were some new tools available to make a much more powerful tool. So I'm going to turn off the zero edges, and you can use the advanced zero edges along with this zero edge built into the function editor, or built into the terrain editor. I'm going to go ahead and edit the function, and we're going to go ahead and make a few changes. Actually, I'm going to click OK and change this over to the world mapping mode. Click No. I'm not going to preserve anything. I'm just going to go ahead and delete the multiply by a constant, which is only needed for the object parametric or world parametric mode. We're going to go ahead and replace the fractal with a terrain fractal. And if we go up to the top to our preview options, I'm going to go ahead and set this to 2D plane, and let's take a look at 100 meters. So that should be about half of our terrain. Now, if you're wondering, in case you are not quite sure why that multiply by constant is added for the object parametric modes within Vue 9 and was never needed in Vue 8, that's because of the scale change for terrains. Terrains basically output a correct scale now, except a procedural terrain on the z-axis only outputs a view unit. The actual amount in the real unit is not correct. In that case, you would have to use a view unit to match things up in graphs. With the scale change, we went from basically, I just want to just explain this really quick. When you right-click on a standard terrain, you can set up your terrain width and size. So we have 256 by 256, and this is a pixel amount for a standard terrain, or also controlling material layers and things like that. Originally, in Vue 8, in earlier versions, it would create a terrain that would be 25.6 meters. Now the terrain is 256. So it makes a big difference with the way the entire unit system works. So now with the object mode, the multiply by a constant is pretty much added to all of those object and parametric modes. Okay, so let's go ahead and take a look at the Advanced Zero Edges tool. You can load this in, add filter, MetaNodes, Advanced Zero Edges. Now, a couple of different options within here and different ways to control this. If we take a look at the input nodes at the top, there is the altitude, and what we do is connect that to our current function, whatever terrain we have. The next numeric input is the distortion, and we'll take a look at that in a minute. And then we also have the ability to use the position input outside of the node, you'll find that a lot of the different tools within snowFlaKe have built-in position options for things like this. But if you want to use an external position, in other words, this top position input, rather than using the built-in position type, then you can do that. In this case, the object parametric mode is desired for controlling this because it's going to lock to the outer bounds and the size of the object itself. Because what we have with the advanced zero edge is a subtraction around the edges. It doesn't necessarily have to be a subtraction. It can also be a way to offset features within a specific area. So there are two main modes. If you take a look on the bottom, there's an offset mode. And what this will do is just raise up the terrain based on our shape. When the offset mode is off, it reverts to the multiply mode. With the multiply mode, if you take a look at the output, setting the exterior or the interior to 0 will remove all detail because we're multiplying the terrain by 0. So if we did both by 0, we shouldn't have anything showing. So if we want to subtract the center portion, we could just reverse that. So the interior height is 0 and the exterior is 1. This will also raise the level. So if we raise this up to 5, we can see, because what we're doing is we're multiplying. So we're adding to these areas. You may want to avoid very high values when you have fine details, because what you can see is some spikes showing up in different areas. So we're going to bring that down to 2. The force extension amount is a way to basically offset the input. So we're offsetting this terrain fractal because it does fall below or very close to 0. So in that case, our subtraction, we have a bit of it going underneath. So if you want more of a mound, you can offset it and force the extension up to raise it above so that the value that's being multiplied is raised up a bit higher. You can also go down to the negative values to subtract and use the zeroed edge, the advanced zeroed edge as a negative. Of course, it really depends on which way you have your exterior and interior height. So by default, our distortion input is automatically set up to use the altitude. So if you take a look in the distortion turbulence section, and this is where the really cool stuff of this node takes place, and some of the more advanced controls. Since use altitude auto mode is turned on, we have a distortion based on the altitude. If we turn that off, what we're going to see is our shape. The shape is right now a circle. We could change it to a rounded square. The rounded square is sharper, and the square. So we're going to go back to circle. Personally, I like going between rounded square and circle. They seem to work out pretty well, although the sharper edged versions can be really neat for creating harsh cutoffs for peaks. So those are all pretty useful. So if we go back and turn on the distortion, we'll see, based on the altitude, everything kind of being distorted around. So using the numeric function itself in order to manipulate basically the distortion shape or our subtraction shape. We have the ability to invert and choose which area of the distortion will be applied, whether the high or the low value, and we can also offset the distortion to return a higher or a lower value. Now, the next function is the bypass smoothness in auto mode. That's because the equalize smoothness and distortion smoothness are controlled by the distortion input. So if you want to control the smoothness by another input, we'll go ahead and add another terrain fractal and switch it over to billows and connect that to our distortion. We're going to control the smoothness or the transition edge with this other fractal, but we're still using the altitude, so we're bypassing the smoothness when we're using the auto mode, which is the use altitude. If we turn that off, then it's going to use the altitude to control that smoothness or the transition and the fall off to the edge. If we go ahead and turn both of those options off, now we're controlling the distortion directly with this terrain fractal. So we're going to make a few changes to the original fractal. And we can modify this and see how it is impacting the shape of the terrain. And I just went ahead really quick and rearranged my interface a little so we can see the terrain a lot better. So if we take a look within the distortion turbulence, what we have is the ability to change the intensity of our turbulence based on the individual axes. So the x, y, and the z. Z is pretty much going to be null for the most part, but we are manipulating a vector. And when you're working with planetary terrains, the z will not be null. It is only null when you're working with non-spherical scenes or basically non-planetary terrains, because otherwise the z axis is not used or even output at all by the function. And that's a recent change. Back in View 8, I noticed that when I went into any fractal or I manipulated the vector and just set the z to 0, terrains would render faster. The only problem is you would get more tearing, and around the edges and certain features, you could run into some issues. Well, that's now built in to pretty much all of the terrains, unless you're using a planetary terrain or if you define your own input node. So if you're having issues with the z output not coming out of a function, or even seeing artifacts within a terrain, you can actually remove those artifacts by adding an input node position options and using the position options input node instead of the starting input node of a terrain function, because that does cut out the z, and when you have an external dependency, there is no z output. So if you do want that available, then just add the position input node. We're going to stick with the default for now, and like I said, it is quicker. It does render faster. I did a lot of tests in View 8 when I discovered it, and I did training for Terrain Workshop, and within the booklet that comes with it, it's called the 0Z technique, which describes all of that. So it is going to render a bit quicker, and it also cuts down on some of the roughness and distortion around the edges of terrains, and does change the roughness output. So it's still good to start with. Changing it over to the position options is not really going to modify too much. One difference between the 0Z technique when it's performed directly on a fractal is that any origin offset on the Z is null and it doesn't impact. So this is something that's really cut off towards the end, because we do see a change in the Z as we're working with the function, but once it reaches the altitude, and clicking on the altitude doesn't show the cut, but outside of the terrain editor you will see there's no Z. And if you do want to see that, we can add an output node custom dependency. And we'll just go ahead into the material, add input node external dependency, procedural terrain, choose. Actually, we do have a built-in altitude input within the zero edge function, the advanced zero edges. The little icon looks like mountains within it. We could use that one too. This one does basically already have a subtraction, so we'll go and switch to the custom dependency I just created. In order to be able to see the output, we do need to add in a constant node, connectable constant number, and connect that number to the external dependency. So if we take a look, the Z is completely null. There's nothing there. But if we go back into the terrain, and we'll just do this really quick, add in input node, position options, change that over to world standard, which is what we're currently working with, and close this out, and then go back into that material and take a look at that link. We can see the Z now has depth to it and information being passed through. So I thought that was really important to note because it is a big change with the way you work with external dependencies from terrains and also linking terrains to each other. So one thing to pay attention to. Okay, so back to the Advanced Zero Edge tool. The axis intensity, which is what we were talking about before, for the distortion turbulence, what we can do is increase the distortion per axis by increasing the number. And what it does is multiplies this numeric value. Now, the distortion turbulence is basically the numeric turbulence node that I created. And you can find that MathNode, MetaNode, and numeric turbulence. What this does is it takes a numeric input and returns a vector. So it can be used as any other turbulence node that you connect to an origin output of fractals. One thing you can do within this numeric turbulence is decide which axes you want to use or distort. It has a built-in combiner for that vector. So if the option is checked off, regardless of what's on the setting, in this case Z, so even though it's multiplied by 2, Z is going to return a value of 0 for that vector. One thing you could also do is type in 0. That will actually automatically cut it off. But one way to kind of check and see what changes are being made, the checkboxes are nice. So that's basically built in to the advanced zero edges. So we can set that to 0, and now we're not going to have any distortion on the X, and we just have Y distortion. And like I said, Z doesn't really do much with this type of terrain. Set that to 0, and we're going to see no change, regardless of the input that's being used. We'll go back to the other position input, because like I said, it does end up being faster for the renders. If we do notice any artifacts or problems, cracking or breaking of the terrain, especially around the really rocky areas within terrain fractals, I've noticed, you can have some holes that show up within the terrain, and that's because the geometry amount is really being reduced, and the roughness value is removed. One nice thing is, even though they did implement that into the software, it doesn't destroy the noise or the function preview that we see for, in this case, the terrain fractal. In View 8, when you would remove the z-axis, and depending on the values you would set for certain origins, you would basically have no detail whatsoever in your preview, even though it would render with detail. Another thing too is that zero edge thing also changes the output of the second output detect rough areas. So if you have any issues with using any of the presets that were originally created in View 8, that's typically the cause of why that second output isn't controlling a material correctly. But for the most part, it works out all right. So we're going to go ahead and zoom back out. And we could even divide and reduce the multiplier a bit. 0.1, so if we just want a tiny bit of change, or we can bring it up to a very large amount of change within a certain axis. So the axis intensity is for that turbulence. The overall intensity is whether or not it's being distorted. So at 0, there's basically no distortion, or at least very little. And then you can change that overall amount. And I did make sure that that is unlocked. In other words, you can go over a value of 1 and it's not clipped. Some tools within snowFlaKe will have clipping on the ranges of the sliders because they tend to cause really big issues. And one of the main reasons for a lot of the tools is really to define the areas that are going to work the best. It's not found often. Most of the time, those sliders are clamped or clipped out at a certain range because the view controls themselves are clipped out for controlling certain things. Now, if you don't want to completely remove everything from the edges, you can add or use a value other than 0 for the exterior height or the interior, whichever one is going to be the low value. So we could add and just have 0.1. And we could also do negative 0.1. And then the height, we can choose to create the subtraction. So you can dig out some pretty neat trenches and canyons with this. If we take a look over in the area controls where we have our shape, there's an X and a Y size. Right now this is set to 0.5. 1 is basically the full extent of the terrain. Which is why the object parametric mode is used, because the value of 1 becomes the full size of the terrain. Makes it a lot easier to adjust this. And it's reduced to about half because of the distortion turbulence. Depending on the input that you have for your distortion, if we grab this terrain fractal and we increase the gain, it's going to increase the output and shift the edge off center. So within the advanced zero edge controls, you can control the center and offset anything if needed in order to keep it in the center of the terrain. Since we have a world terrain, we can basically resize it, but keeping in mind that we'll also resize our subtraction because we're using an object parametric mode within the object. So if you need to keep an identical value, then you can switch it over to a world standard. But as you can see, our subtraction is very small. So this is going to be relative now to the size of the terrain, which is 256. Or just about, really, depending on the distortion. I'm going to bring it down to 128. Go further, maybe 64. That will also impact the way the vector works for the distortion. Because we need a much higher value now, because before we were working with 0.5, and that's basically kind of a vector value. Now our vector to equal the same area is 64, so we need a much higher output of axis intensity, So what you can do is multiply the number, probably change the scale of that terrain fractal, and also increase the intensity. So depending on the mode you're working with, it will require different values. I'm going to go ahead and switch this back to the object parametric mode and reset those axis intensities to 1, overall intensity to 1. Now if you take a look, our edges are getting rather sharply cut off. This is because of the distortion smoothness, and because I have the gain set a little higher. The higher the gain output is of the controlling distortion, the sharper the cutoff is going to be. Because basically, the smoothness is going to require a value between 0.1 to 0.3 up to 1. Now, you won't be able to go down to the lowest value because it does create very strange artifacts. So it is automatically clipped within the node to never go below, I believe, 0.3. It might be 0.03. And actually it is 0.05, so it'll never fall below 0.05. So depending on the distortion, we can change the gain to smooth that out, or what we can do is use the smoothness values. So our distortion smoothness, lowering it is going to create a sharper cutoff. Increasing it up to 1 is going to give us the full blend and a full amount of smoothness based on the fractal, or whatever the distortion input is. So you can adjust that range. And there's also an equalized smoothness, which is pretty helpful. So it's a bit of an offset as well as a subtraction. The way the equalize smoothness works is it takes the distortion smoothness input, multiplies it by 2, and then subtracts itself. So that becomes incredibly helpful for balancing out that control. One cool thing you can do is right now we have an equal x and y. If I go ahead and take our y and set it down to 0.1, we're going to have a nice carved out canyon, or it could be a riverbed depending on the size. In this case, it's still confined to the x of 0.5, so we can increase the x. And we'll go ahead and modify the distortion. So if we reduce the distortion now down to 0.2, we see more of the original shape. So now you can start to distort that with the axis amount. And remembering too that if you just want to cut this stuff or cut this feature out of the current terrain, you can switch it over to the offset mode, which will preserve the current terrain, but just take that area that was basically the main feature before and just reduce that section. So it's a cool way to kind of cut stuff into it. And since this is mostly off-center, because we changed our center, we can reset those values. And remembering too that as we change this distortion, we're going to end up with some really interesting looking subtractions. And now we're looking at this as something being carved out, but if we did want to reverse that, we can make that a bit of a mountain. This is also works awesome for creating islands. You can get some really neat islands out of it. And I'm going to go ahead and modify the bump surge. And we'll add a bit of distortion within the main fractal, and going back into the advanced zero edge and setting our exterior height to 0.05. So that way we don't have a whole lot of detail on those edges. We want it to remain mostly flat, except for where the mountain areas are showing. And one thing we could do is reduce our interior height, but increase our force extension in order to prevent some of those spikes from showing. That's one way to keep your shape a little bit better. So instead of adding a very large exterior height, which will just make it very spiky because we're multiplying it by such a high value, reduce that amount and increase your force extension. So a lot of cool stuff you can do with this filter. So when we were in the material before, you got to see that external dependency that's part of the advanced zero edges, which is that altitude output with the two little mountains within the brackets. So that is the altitude output of the advanced zero edge. So if you have any connections between the advanced zero edge and the final altitude, that won't be part of that output. So if you need to add a custom dependency for that, you can add that in. For more advanced distortion of the subtraction, I'm going to go ahead and change my scale output. And we'll go back into that terrain fractal, reduce the gain, and change our scale. What we can start doing is extracting. There's a couple of controls that can be extracted to control the mixing variation. Things you wouldn't really want to control are the X size and the Y size. Distortion smoothness is automatically controlled by the distortion, so you really wouldn't need to extract that. If you wanted the smoothness to be separate than the distortion, then yes, you could add something additional to that. Using the overall intensity, extracting that, connecting it to a fractal, the offset modes, or even the height controls can be pretty useful. So one thing I like is the force extension, adding a fractal to that. That can create a pretty nice look. And you may need to increase the gain, or even use an opposite filter on it. We'll set that to ridges so it doesn't dip down so low. And we can go ahead and modify the origin so that it's not identical to the other one. So now our force extension is controlled by this terrain fractal. Keeping in mind it does stay within the shape range. So it becomes a pretty cool modifier. And a nice way to kind of balance things out. Or add little bits of variance and create something more realistic, more interesting looking. Like I said, the overall intensity can also be controlled. and that's for the total distortion. Just neat little ways you can vary your terrain. Keeping in mind you don't want to create too many connections because then it's going to take forever to render. So if you have a function with 20 terrain fractals, have fun rendering because it is a lot of information. The terrain fractal itself is a pretty intensive renderer. So when you start combining, a lot of them, you end up with a lot longer render times, which is usually okay for stills, but when it comes to animation, it can be a little more of a pain. So I'll go ahead and save this current scene in this setup so that if you want to play around with the current terrains that I'm working on right now, you can have direct access to the file, and this will be in the content folder, the project content folder, or snowFlaKe examples. I'm going to just go ahead and center that a little bit. And I'll go ahead and just render this really quick. I am, before I render, going to take that position input and switch it over to the position options world standards so that I don't end up with any strange artifacts or cracking, breaking, tearing, or holes within the terrain. It should help improve the quality. If it doesn't, and you've switched it over, you can edit the terrain and go into the quality boost. It does appear as if maybe they've reduced the quality boost within View 9 since View 8 to get a faster render, but that might be because that removal of the z-axis. So really not quite sure. If needed, increase the quality boost, because I have noticed a little more tearing in View 9 than in View 8, but not that bad, just in a couple of different nodes in certain circumstances. So even without a material, this looks pretty good. Up at the top peak, you can see a bit of distortion, some darker spots that are showing, along with a little bit on the edges. And that is what I was talking about with the terrain fractal. It's just something that's seems to be more recent. Of course, most of the time, your material is going to cover that up, so it shouldn't really be a problem. It could also be, in this case, since it does seem to be more centralized, the rougher or smaller features of both of the terrain fractals being multiplied by each other and creating more of an extreme value when they meet. So one thing you could do is increase the smallest feature value of either the distortion or the main input. Probably not even by much, not enough to remove any detail, but enough to maybe remove some of those spikes if that is what's causing it. It's not always going to be the case, because a lot of times the distortion that's built in to the terrain fractals can tear in some cases. So if you want to load in this file, it is called Advanced Zero Edges Setup.